Hello everyone, and today this is Lead Code September Challenge, and this is a week 1 challenge. And today we have our first question, which is array nesting. So let's try to solve this problem. First, read the problem statement, and then we will try to understand the approach and solve this problem. So the problem is we are given an integer array nums having length n, where nums is a permutation of a number in the range of this. So the question is very straight and forward, that we have an array and this array have some values, and the values is between, if the length of the array is n, then the range of values is from 0 to n minus 1. Now the problem is we have to build a set, okay, and we have to build set in such a way that if we have some k index, and for that index whatever the value we have, okay, we have to go for that index, and similarly we have to go for this nums of k index, and similarly we goes on until and unless we find the same value which is present in the set. So the problem is that we have to return the maximum length of this set. So first take a test case and try to understand the problem and then move on. Sorry. So let's take one test case and try to solve it. So this is the test case we have. Okay. So this is the test case I have. So let's give indexing 0, 1, 2, 3, 4, 5, 6. So let's create a set first and try to solve it. So you can see, if I consider this 0 index value, so it has value which is 5. Now I go to the 5th index value, which you can see there, which is 6. So I put 6 in my set, and we go to the 6th index. Now the 6th index have 2 as value. Now we go from there to 2. Now from this 2 we have 0 value. Now again when you go for 0, you have 5 which is already present here. So for this we have a length of 4. So for this set we have a length of 4 if we start from this 0th index. But if we start from, sorry for this, so if we start from the first index, let's suppose this one. So let's create another set so that you understand the problem, how it's going on. So you can see, if I go to 1, we have 4. Then we will go to 4 and it says it is 1. Now we will go to 1 and it is again 4. So we will stop there. Similarly, we find all the sets that we have in this problem, and whatever the maximum length of the set, we are return this as our answer. So this is the first basic approach that I will taught you, that we will work on each index, we will find set for each index and make a variable answer, and compare it with the all set lengths, and whichever the set has a maximum length, we return it. I hope this thing is clear. So if you try to solve this problem by this approach, there is a time limit exceeder error. Why? Because for each index you are trying to traverse whole, right? So for each index you are trying to traverse whole. That is why for each index n you have to traverse n minus 1, and its time complexity is O of n square, which is not good. Now we try to improve this. Okay, So see, as you can see in this problem, we will move from one index to another, and whatever the value of index, and then we will move to that index. So in my YouTube video, you can see there is a Floyd detection algorithm, which is basically we use to detect this cycle. Okay, so now you can see there is a cycle. As if there is a 5, the 5, if we go to the 5, there is 6, right? And if we go to 6, there is 2, and if we go to 2, there is 0, and now if you go to 0, there is again 5. So again at this position the cycle comes up. So we can create a variable, or we can create a container and name it as a visited one. Why we will make a visited one? Because like if from 5 we visit 6, and from 6 we visit 2, from 2 we visit 0, then why we again visit these more values? Like if I am trying to compute from the second index, so it will point to 5, but 5 is already computed, then why we have to compute it again? So we can create a visited array, and here we store like which element, or which element is visited. So to solve this, let's make a iteration so that you can grab it. So the size of this visited array should be same as an 0, 1, 2. As you can see, this is 1, 2, 3, 4, 5, 6, and 7. So this is 0, 1, 2, 3, and this is 4, and this is 5, and this one is 6. So as first we visit this one, so let's make it true. Then from 5 we will go to 5, so let's make it true. So after 5 we will go to 6, let's make it true. From 6 we will go to 2, let's make it true. And from 2 we will go again to 0, which is already visited. So we'll stop at this point and make a counter as well, which counts the number of edges we have. So at that time we have 4. Now we will go for the next index, which is 1. So when we go to 1, we will check if 1 is visited or not. So 1 is not visited, so we will go for 1, and from 1 we will go to 4. So now we visited 1, now we visited 4, and from 4 we have to go to 1, but which is already visited. So here the counter value is 2. Okay, so let's make an answer variable where we store our answer. Previously we have 4, but now in this we have counted as 2, and now when we compare it, it is not greater than 4, so we will not change it. Now we will move to the next index, which is 2, but it is already visited, that's why we don't have to visit it again. Now we go to 3, the 3 is not visited, so we will make it true. From 3, where we have to go? We have to go a 3, so this is a self loop. So we have to stop here, and the counter here is 1, which is not greater than our answer we have, so the answer is 4. So here in this, the time complexity we have is big O of n. As in the worst case, we have to check each index, and the space complexity, as you know, we are using this visited, so this is big O of n as well. Now this problem is also fine, but the interviewer is not happy with this extra space we use here. So to remove this extra space, we will think like how we can remove this extra space. So the simple thing, you can see one thing here. If I visit some index, after that we don't have to use it. So we can do one thing, and in the problem this is also mentioned that our value of array, or the length, is from 1 to this and 0 to that. It means there is a no negative value, so we can make use of it. What I am trying to say, let's suppose if I go to 5, So what I will make, I will make the value 5 as -1. Okay, and then we will visit after 6. So we will make its value to -1, or whatever the value you can say in the negative way. And after 6 we will go to 2. Let's make -1 in the same array, and from 2 we have to go to 0, and let's make -1. And from 0 you can see we have to go to, from 0 we have to go to 0, which is the same thing. So we have to stop, and we can make use of counter. Now whenever we are checking for next indexes, we will check if it is -1 or not. If it is -1, we don't again compute for that, because it is visited as well. Okay, so this is the way how we can make our space complexity from big O of n to big O of 1. Now it's time to discuss the code. So let's go to the code. So that is the code, which is very easy and simple as well. And my recommendation is, please pause the video and try to write code on your own, which helps to improve your syntax or language. Okay, so now let's come to the code. So first we will create an answer as 0, as we have no answer. So we will create a variable, and then we will check for each element, because what actually we did, we actually work for 5. This is the element of array. Then we are actually work for 6, right? So how we can do it? We are going to, let's suppose the x is initially 5. Now it is not -1. It means it is not visited till now. So we are creating a counter, and the same thing happens. So we are checking if its value, if x is playing as a index, if that is -1, we will not go to it. If it is not -1, we will increment our counter, and what we will do, we will change our x with num of x. What does that mean? Understand it. So here we have x as 5. Now the num of x, which is num, means array at the 5th index, which is what? 6. Now this 6 is becoming our next index to be explored, and whatever the value I am exploring, which is nums of x, we will make it -1, and at the end we will simply compare which one is maximum, and at last we return it. So this is a separate solution. So I hope you like this video, and if you like this video, please like, share and subscribe, and also feedback me in the comment so that I can improve it more. Thank you.